All right, let's take a look here at 6.6, and we're going to be solving exponential and logarithmic equations. Let's go ahead and jump right into it. We are going to take two lessons for this right here. And to start off, we're going to talk about the property of equality for exponential equations. So what does all that stuff mean? Pretty much right here, you can see in the example that's shown in this core property, is that if 3 to the x power is equal to 3 to the fifth power, x is equal to 5. So bottom line right here, if the bases are the same, okay, if the bases are the same, then I can take the exponents and then set them equal to each other and solve for x. All right, but the key thing here is that the bases must be the same. So they give you an example, you got 3 to the x is equal to 3 to the fifth. In the end, x is equal to 5. All right, so pretty simple. But the key here is getting the bases to be the same. As we go ahead and move along, next up we have the property of equality for logarithmic equations. Well, if we have logarithms, in order for us to set the equations equal to each other, is that their log bases must be the same. So in the example right here, we have if log base 2 of x is equal to log base 2 of 7, then I could take x and set it equal to 7, and there you go. Just like that. Pretty simple. So let's take a look at some of this extra practice right here. So in our first problem, let me zoom in a little bit. We have 5 raised to the 2x plus 4 power, and that's equal to 5 to the 5x minus 8 power. So since the bases are the same, all I need to do is to take 2x plus 4, and I could set that equal to 5x minus 8. Once again, I can only do that if the log bases happen to be the same, which they are right here. So let's go ahead, I'll subtract 2x to both sides, and let me add 8 to both sides. So 12 is equal to 3x. We'll divide both sides by 3, and x is equal to 4. All right? And just like that, we have our answer. Okay, but the thing here is we're not always going to have the same base, as you can see as in number 2. So this is where the fun begins. How can I get the bases to be the same right here? You know, how could I get 4 and 8 to be the same? Remember, we've done problems where we've manipulated the base and we gave it an exponent. That's something we're going to have to do right here. The equivalent of 4 is going to be 2 to the second power. Right? That equals 4. And the reason why I chose that is because right here, I can get 8 by using a base of 2 and changing this 8 into 2 to the third power. And so therefore, I have both the same bases now. Now here's the next part to this. I've got to include right here the 2x minus 1 as the exponent. And let me go ahead and space things out a little bit better right here. All right, so there we have our equation. Now, the bases are the same. So let's take the exponents. We'll set things equal to each other. However, we got to remember that when I raise a power to a power, or as you can see right here, with the exponents, 2 and then we got ourselves 2x minus 1, we need to go ahead and multiply all of that together. And so I now have 4x minus 2, and that's equal to 3x plus 6. And be sure to simplify or distribute first, and then we'll go ahead and simplify things out. We'll subtract 3x to both sides and add 2 to both sides, and x is equal to 8. And there you go. All right, just like that. All right, let's take a look at the third example right here, number 3. So bases aren't the same. There's no numbers that I know of that where I could take 3 and somehow turn it into a base of 5, or 5 can turn into 3. So the next step right here, what we're going to do instead is get rid of the 3, and in order to do that, the log bases have to be the same as the base itself of what it is of. So here's what I'm going to go ahead and do. I'm going to go ahead and multiply both sides by log base 3, and then this is part of the original equation. And then we have right here on the right hand side log base 3 of 5. Okay. So what that will now do for us here is that the log base 3 of 3, that'll go away. And I'm now left with x plus 3 equal to log base 3 of 5. And I can't really do anything with that right now. Okay, I have to keep that as is. Let's go ahead now and get x by itself. So I'll subtract 3 to both sides. And I'm almost to my answer. Okay. I can't really do anything else with this at the moment because my base is not a base of 10. I can't just plug it into the calculator unless you happen to have a fancier calculator. So remember what we just learned in 6.5. We learned change of base. I could take this log base 3 of 5 and rewrite it using change of base to use my calculator. And so let's go ahead, I'll rewrite this as log 5 over log 3. And then we have ourselves minus 3. And so at this point, you're going to have to go ahead and use your calculator, plug things in, and we round it to the nearest, was it the thousandths? We get approximately negative 1.535. And there's your answer to number 3. Right, so quite a few things happening in problem 3. So that's why, I try to take 2 days doing this lesson. Because the next part of it, as we get to it tomorrow or the next time I see you, you'll see the differences there on how the foundation of this first part is essential for the next. All right, so let's take a look next up at number 4. All right, so we encounter a few things again right here where, hey, our bases just don't look, they're not the same. So let's see what we could do. First off, let me take this rad 25, and I'll change this to 25 raised to the x to the 1/2 power. So I went ahead and took the radical and rewrote it. And so hopefully that part you understand at this point in time. We've done this enough times as is. Well, how can I get 1/5 and then all of a sudden maybe turn that into 25? How is that possible? Or can I take 25 and turn it into 1/5 as a base? It's usually easier to deal with whole numbers and fractions. So this is what we're going to do right here. I could rewrite this 5 to the 1 over 5 and rewrite that exponentially, turning this into 5 to the negative first power. Okay, now we've dealt with you know, inverses and all that stuff already, so hopefully you already understand why that works out. Okay, the how 5 to the negative first power, and I'll put it right here on the side. That right there is equal to 1/5. Okay, I'll have that on the side, but that's pretty much why, or shows you where those numbers came from. Now, we have the 25 x raised to the 1/2 power, or that's equal to, when we raise a power to a power, we're multiplying. So I'll go ahead and simplify that right there, and then change that to 1/2 x. But I can't really do anything yet because the bases aren't the same. How can I take that 5 and turn it into 25? What if I square it? Okay, so what's going to happen right here is I'm going to go ahead and change this to 5 to the second power. We still have the negative 1 there. And then if we were to get, for the sake of neatness, I'll go ahead and put that in brackets, and then we got 3x minus 2. So that 5 squared becomes 25, right? Actually, you know what? Let's pause for a moment. I'm thinking about it. There's another way we could go about doing this. How about we take that 25 and turn that into a base of 5? That'll be a whole lot easier. So this 25, let me change this to 5 to the second power, and then we raise that to the 1/2 x. And let's go ahead with, on the left-hand side, I've got 5, and I'll go ahead and distribute the negative 1, and I got negative 3x plus 2. So now we have the same base. And we can go ahead and start simplifying things out. Bases are the same, so we keep the exponents equal to each other. I've got negative 3x plus 2. And this 2, when we raise a power to a power, we multiply that with the 1/2 x, and that'll just be equal to x. We'll get x by itself. Let me add 3x to both sides, and I've got 2 is equal to 4x. Divide both sides by 4, and right here on the side, I'll put x is equal to 1/2. And there you have number 4. All right, we want to try to get the bases to be the same. And that's what we did right here on 4. We had to do a few steps before we could actually get to that part. You can see on the left, taking that inverse. Okay. Next up, let's go to number 5. I erase some stuff here, give some space. And before we do any sort of like base changing and all that stuff, let's see if we could get the variable by itself, or as close to as by itself as we can. So that's why right here on number 5, I'm going to start off, divide both sides by 12. Okay, because 12 times e to the 1 over x, negative x, or 1 minus x. So I can start off and subtract or divide both sides by 12. I'm now left with e to the 1 minus x power is equal to 500 over 12. And we could leave it as 500 over 12, We could simplify it. If you realize, hey, I could simplify this. Actually, let's keep it as is for now. Eventually, we will have to simplify this. So now, I've got a base of e. How do I get rid of that base of e? Something we learned earlier is that now we can go ahead and multiply both sides by ln. Because now that gets rid of that e, and I can have my problem as 1 minus x is equal to ln 500 over 12. And let's put that in parentheses right there, especially when you plug things into your calculator. I'll go ahead at this point. We'll subtract 1 to both sides. And so it's minus 1. And then we have the negative out in front, which we do not like. So we'll divide everything by negative 1. And so we got ourselves negative ln 500 over 12 plus 1. And there you have it. We now have our answer. Positive x, or x is equal to negative ln 500 over 12 plus 1. You go ahead, at this point, you plug that into your calculator, and we get approximately negative 2.73. All right, there you go, negative 2.73. Let's take a look at our last example for this first part. All right, so let's see what we can do right here. Let me erase some of this. And take a look at number 6. Okay, so hopefully first things first, let's subtract, or let's move that negative 14. So I'm going to add 14 to both sides. So I have now 3 e to the x power is equal to 11 plus 14, which then gets us 25. Okay, so let me go ahead and change that to 25. Next up, let's get rid of that 3, and I can simply do that by dividing both sides by 3 right here. And I now have e to the x power is equal to 25 over 3. All right. We now get rid of the ln, or get rid of the e, by multiplying both sides by ln. We did that similar step right here on number 5. And so now I have x is equal to ln 25 over 3. And once again, when you plug things into your calculator, you should have that 25 over 3 in parentheses. Okay, and that'll help you get your correct answer. And when you start plugging things into your calculator, x is now approximately 2.12. All right, so that right there gets us through the first part of 6.6. As you do the homework, you're going to have a variety of steps that you're going to at your disposal, or a variety of ways to solve the problems, and there might be a few others that you're going to be seeing. All right, until next time, hopefully good luck on your homework.